Hello everyone, welcome to the Electron Flow Academy. Today we are going to solve that numerical problem which is based on the series RL circuit. Okay, which is based on the series RL circuit. So, question is given as that the coil is having a resistance of 3.5 ohms and the inductance of 0.07 Henry. Okay, so is connected across the voltage of 220 volt and 50 hertz supply. Okay, next, what we have to calculate here, find the current drawn from the supply. Firstly, we have to calculate the current and power factor of the circuit. So the two things are here asked. So basically, here the given is to us the solution is given. Here we have firstly is resistance, which is R, is equal to 3.5 ohm. Okay, and the value of inductance is given as to 0.07 Henry. So we know that the XL is equal to nothing but the omega L, or omega is equal to 2 pi f L. So here we have to calculate the value of XL. So 2 pi into the frequency is given to us is here 50 Hertz. 2 pi into 50 into 0.07. So the value of the XL is now equal to 22 ohm. Okay. So this is we have to calculate. Now we have the two values, the value of the resistance and the value of the XL. Okay. So as per the question, if I draw the diagram here, like we have the resistance which is connected in series with the inductor. Okay. So this is our resistance and this is our XL connected across the AC voltage source like that, whose value is voltage is equal to 220 volts, and we have to calculate the current I. Okay. So next thing is that here we need to find out the total value of impedance. Now the Z is equal to, we know that R plus J times of XL. Okay. So put the value here of XL and R. So R is equal to 3.5 plus J of XL, which is we just calculated 22. Okay, now the value of the Z is 3.5 plus J22. So this format is in rectangular form. Okay, this is the rectangular format. Okay, now we need to change this format into the polar form. Polar form, with the help of the scientific calculator, I have changed this rectangular form into the polar form, and I get the value in the terms of R at an angle of theta. So now the value of the impedance is now 22.276 at an angle of 80 degree. Okay. So here let the capital V the reference voltage. So the current is drawn is now here the current is equal to, we know that the voltage is our reference. So we are assuming that the voltage is at an angle of 0 degree divided by Z. Okay. So the value of the current is now 220 at an angle of 0 degree divided by Z, which is equal to 22.276 at an angle of 80 degree. Okay. So the value of the current is now 9.87 at an angle of minus 80.96 degree. So this is our first answer in ampere. Okay. So while we are dividing the two polar quantities, the angle will get the subtract. Okay. So the from the numerator angle we have to subtract the denominator angle. So here we have the 0 degree. So the angle will be the 0 minus 80 degree now. So that's why we have the value of the minus 80 degree. And the ratio of the 220 divided by this 22.276, which is equal to the 9.87. Okay. So here we have calculated the value of the current as asked in the question. Next. So while looking at that angle which is minus 80 degree, so we can say that the current here, current lags the voltage V by 80 degree. Okay, 80.96 degree. Okay, 80.96. It is also 80.96. That's why we get the 80.96. So next thing is to calculate the power factor. So we know that the power factor is nothing but the impedance angle. So power factor equal to cos of 80.96. The impedance angle is with the cos is give us the value of the power factor. So the power factor is now equal to 0.157 lagging. Okay. So this is lagging because of the RL type of the load. Okay. So if I draw the phasor diagram will look like for this circuit is like that. This is our supply voltage, which is equal to 200 at an angle of 0 degree. So from this is the reference vector. So from this reference, the minus 80 degree apart the current. So you can assume that this is our minus 80 degree. This angle is 80 degree, 80.96 degree. So this is our value of the current, which is equal to 9.87 at an angle of minus 80.96. Okay. So this is how we have calculated the current and the power factor. So thank you very much. Kindly like and subscribe our channel.